Yes. A very warm greetings to all of you, respected chief guest and the keynote speaker of today's program, Professor R.K. Kotnala, Chairman, National Accreditation Board for Testing and Calibration Laboratory, NABL, and Raja Ramana Fellow, Department of Atomic Energy, the Director, CSIR-AMPRI Bhopal, Professor Dr. Avnish Kumar Srivastava, distinguished guest, respected dignitaries, scientists, researchers, students, ladies and gentlemen. I, Dr. Sarika Verma, extend a very warm welcome to all of you on this very, very special occasion to celebrate the Festival of Science and Technology, that is a National Technology Day in this hybrid mode. It's really a proud moment for all of us that today's chief guest is physically present in our campus. I want to share it with you. And before starting of this program, he had a visit in our campus. Thank you so much, sir, for accepting our invitation to celebrate this occasion. And thank you for sparing your valuable time to celebrate this occasion with us. Sir has visited the laboratories and he has seen the work that EMPRI has been doing during these last years. Thank you, sir. As you all know that, ladies and gentlemen, this 11th May has been declared as a National Technology Day in India by Government of India to commemorate the first of the 5 nuclear bomb tests which were carried out on 11th of the May 1998 by the Indian Army at Pokhran Test Range under the name of Operation Shakti. The day is to memorize the anniversary of Shakti, the Pokhran nuclear test held on this day. The day glorifies the importance of science and technology in daily life and motivates the student to adopt science as a career option. With these words of hope, igniting our minds to fulfill the purpose of this special day and directing all of us into a new era of advanced technical and scientific innovation leading to the betterment of humanity, let's celebrate this special day today. To start the program with, I would like to invite Director CSIR-AMPRI Bhopal, Professor Dr. Avnish Kumar Srivastava for his welcome address and opening remarks. But before that, I would like to share his list of achievements. Although he has a very, very long list of achievements, which is very difficult to put in the words, I'll share it with you. Professor Srivastava earned his MSc Honors in Physics from IIT Roorkee and Masters in Technology in Material Sciences from IIT Kanpur. He holds PhD degree in meteorology from IISc Bangalore. He is known for his knowledge and expertise in the field of materials processing and characterization, semiconductor science, nanostructured materials and composite, and so on. He has more than 325 publications in high impact journals with more than 11,000 citations with his work also highlighted in Science. He is also editor of many books which are related to the nanomaterials, semiconductor, etc. It's our privilege to mention that Professor Srivastava, Director CSIR at Bhopal, he has been recently identified by Stanford University among the top 2% most cited scientists all across the world. Along with the deep knowledge on the fundamental sciences, he has also the command on the technology development, and he has more than 25 patents in his credit and almost the same number of know-hows in his credit. He is currently serving as a chief editor for the Applied Innovative Research Journal, and he has been very instrumental in establishing various research facilities in CSIR NPL as well as in CSIR NP Bhopal. Among various facilities, one of the most important facility that has been established by Director CSIR-AMPRI are transmission electron microscopy and electron energy loss spectroscopy that are very few all across the country, as all of us know. He has been the fellow of number of organizations like IIM, MRSI, Mineral Metals and Material Society USA, EMSI, and so on. It's our great pleasure to mention that now Professor Srivastava is the president of Electron Microscopy Society of India. Number of awards listening. Some of them are from the Ministry of Steel, MRSI Medal, INSA COSEF Fellowship, Boycast Fellowship, NRDC Social Innovation Award, and so on. Professor Srivastava is also serving in various committees of Ministries of Science and Technology like TIFAC, DST, Standing Scientific Advisory Group by Ministry of Mines, and so on. He has also worked as National Coordinator in Bureau of Indian Standard and contributed in the field of nanotechnology. He has worldwide collaborators where he is closely associated with various institutes. Some of them are Argonne and Brookhaven, National Laboratories of USA, Technical University Darmstadt, Germany, Department of Energy, Italy, and so on. There is a very, very long list of achievement of Professor Avnish Kumar Srivastava, which is filled with uncountable number of such prominent works and titles, which are really difficult to put them into the few words. Now, not taking much of the time, I would like to invite Professor Dr. Avnish Kumar Srivastava, Director CSIR-AMPRI Bhopal, for his welcome remarks and the opening remarks for the August gathering. Sir, please. Thanks.
Namaskar. Good morning. Wish you all a very happy National Technology Day 2022. आप सभी को नेशनल टेक्नोलॉजी डे मुबारक हो और इसको सफल बनाएं. As our anchor Dr. Sarika Verma mentioned, that we celebrate National Technology Day on May 11 every year to commemorate the achievements of scientists, researchers, engineers, and all others involved in the field of science and technology. The day was first observed on May 11, 1999, and because of three reasons. On May 11, 1998, India successfully conducted nuclear tests at the Indian Army's Pokhran test range in Rajasthan. On 11th May 1998, India also tested its first indigenous aircraft, Hansa 3, which was designed by the CSIR, Council of Scientific and Industrial Research at National Aerospace Laboratory, Bangalore. And the day 11th May also saw the successful completion of the test firing of India's surface-to-air missile, Trishul. And that tests were conducted by the Defense Research Development Organization, DRDO. The theme for the National Technology Day, the year 2022, is Integrated Approach in Science and Technology for Sustainable Future. The theme was launched by Dr. Jitendra Singh, Honorable Central Minister and the Vice President of CSIR. We at CSIR-AMPRI, AMPRI stands for Advanced Materials and Process Research Institute, in Hindi, Pragat Padarth Tata Prakram Ansandhan Sansthan, in Bhopal, is an engineering materials institute under the umbrella of CSIR, and we are working on lightweight materials, nanostructured materials, cement-free and radiation shielding materials, different kinds of some composites, including bamboo-based, agro-waste, marble waste, etc., which also leads to waste to value-added materials, then biomaterials and materials solving energy-related issues. And we are in advanced processing techniques we are adopting, like additive manufacturing and electromagnetic forming for various regions, and rural technologies and water resource management. We also inclined, because of the concept of this Atmanirbhar Bharat, uh, we all also inclined towards making the instruments which should go to the industry. And the first instrument which we thought that it is very useful and it's very logical also to start with is the Raman Spectrometer, because we all know that Sir C.V. Raman gave the concept, rather explained the scattering of light, uh, and he reported on 28th February 1928. And the day is now being celebrated in India as National Science Day. And on this discovery, he also received as first Asian Nobel Prize in 1930. So it was our concept But since then, the full-fledged Raman spectrometer we have been purchasing from outside, and to if we have our own manufacturer which we have identified and we have built it, and first purchase order is also issued. So if we have our own instruments, then definitely it will contribute towards Atmanirbhar Bharat. As we all know, the Atmanirbhar Bharat has got five pillars: economy, infrastructure, demography, demand, and system. So definitely, this concept of manufacturing of equipments in India contributes towards economy, development of skill to our people, and then to limit the foreign exchange which goes abroad. So there are various regions, and once you have your equipment, you can do a lot of R&D and come up with various new aspects in that. In addition, we have CSIR Jigyasa program for school children, CSIR Skill Initiative Development Program for young engineers and researchers, AICT Faculty Development Program on Artificial Intelligence pertaining to engineering materials, and ACSIR for PhD degree in the area of engineering sciences, chemical sciences, and physical sciences. Today, we are very fortunate to have with us Professor R.K. Kotnala, a well-known physicist, material scientist, and also having deep knowledge towards quality system. Currently, Professor Kotnala is holding two very prestigious positions in the country. He is the chairman of the National Accreditation Board for Testing and Calibration Laboratories, NABL, and Raja Ramanna Fellow of the Department of Atomic Energy. And moreover, I mean, which I feel very enjoyable and a very proudy thing for the country, that he was the first Indian scientist from the country to become the associate editor of a very prestigious journal, that is Journal of Applied Physics. So on the occasion of National Technology Day 2022, on behalf of CSIR-AMPRI and also on my personal behalf, I welcome Professor Kotnala ji to AMPRI Bhopal, whom I know since last several years. It's more than 25 years, very close association. We are also signing MOU with PSG Institute of Technology and Applied Research, Coimbatore today, to mainly carry out joint research with the aim to develop bio-based polymeric binding materials. I welcome Professor M.I. Abdul Alim, Head Department of Civil Engineering of PSG iTech, and his colleague on this occasion, who have come all the way from Coimbatore to Bhopal in person for signing agreement with CSIR-AMPRI Bhopal. On this occasion, my warm welcome also extends to all participants of my own CSIR-AMPRI family and all other people who are directly or indirectly involved in this today's National Technology Day program of CSIR-AMPRI. My warm welcome to all of them. Thank you very much. Dhanyavad. Jai Hind. Namaskar.
Thank you, sir. Thank you for your kind words of wisdom. Ladies and gentlemen, all of us know that for last 2 years, we all have been suffering because of the corona. Globally, people have suffered, and at the same time, the opportunity arises to do the research related to this particular area. Related to this, CSIR-AMPRI Bhopal has contributed a lot, and in view of the above, I request Dr. R.S. Ahirwar, Chief Scientist, CSIR-AMPRI Bhopal, to kindly play a video on CSIR-AMPRI's achievement combating the COVID-19. Sir, please.
CSIR Advanced Materials and Process Research Institute, in short we call it CSIR-AMPRI at Bhopal, is one of the constituent labs of CSIR, that is Council of Scientific and Industrial Research. Under this lab of CSIR, that is at AMPRI Bhopal, we work on lightweight materials, smart and functional materials, nanostructured materials, waste to value added materials. And these materials in turn they get converted into different outputs like publications, patents and products, that is technology know-how transfers. It's a national lab of international repute. As far as COVID-19, this pandemic of coronavirus is concerned, we worked on different directions. Being an engineering lab, we try to do our best using our capacity, efficiency and the expertise of our scientific, technical and non-technical manpower. We worked on knowledge generation, knowledge dissemination, industry interface, societal interaction and innovative products. In terms of knowledge generation, we published some very important papers in international journals, including even considering the nanomaterials of graphene, and we are probably the first in the world to publish in Science Reporter saying that graphene can work as a protection material against coronavirus. Other publications like on antimicrobial coating, biosensors, medicinal plants and so on. Then we did knowledge dissemination like organizing conferences, workshops, training the people and also making aware how to protect yourself, how to prevent yourself from the COVID-19. We had these programs under Jigyasa, teaching the school students, their parents, their teachers, their deputy commissioners, principals, and under a skill development program, certain programs we have run. Then we interacted with society in terms of teaching them or making aware how to protect themselves from coronavirus. In this case, we reached to more than 50 villages of Madhya Pradesh and Chhattisgarh. We distributed our masks, sanitizers, soap and posters making them aware about the coronavirus COVID-19. We also distributed our soaps, masks, then sanitizer and posters to government officials like police personnel, bank officials and common man. Then further we worked on different products, technologies we are trying to develop, and we started with face mask and sanitizer with extra skin care. And this technology we transferred to a startup company in Indore, and I am happy to tell you that face mask is already in the market. It's commercialized after lab testing, and sanitizer work is going on. In addition, we are working on to develop different sanitizer boxes with UV and nanomaterials, hybrid boxes, without UV with nanomaterials, hybrid boxes. We are developing some other products like some biosensors and so on. Then we are working on different other products like different high quality masks like e-mask, tribological mask, herbal mask, graphene layer incorporated mask for different sectors of the people, not only to common man but even for doctors and other healthcare people. So in total on different fields we are working. We are developing antimicrobial coating to protect ourselves from this COVID-19 coronavirus, and this coating can be used for different metallic surfaces, and therefore one can protect ourselves. So in total in 5 directions of knowledge generation, as I said, knowledge dissemination, societal interaction, industry interface and innovative projects. In all these directions our scientists, technical staff, non-technical staff, students, project fellows, we are working in one team, and we are also getting associated with CSIR as a whole. CSIR as a whole also has 5 pillars where different directions they are working, and we are associated with hospital assistive devices among 5 pillars of CSIR. With this, thank you very much. Jai Hind. Dhanyavad.
Thank you, Dr. Ayuba. Ladies and gentlemen, how to move ahead. It's our proud privilege. As I shared with you, we have a very eminent personality, Professor R.K. Chitnala, Chairman, National Accreditation Board for Testing and Calibration Laboratories, and Raja Ramana Fellow, Department of Atomic Energy, as a chief guest of today's program. His talk will be focused on a very special and an innovative title, that is the 21st century biggest invention of hydroelectric cell devices to produce clean and green energy, and he will be sharing a brief about ISO 17025. Before I call him for his keynote lecture, I'll just share his list of achievement, which is very big, but I'll share it with you about his expertise and his work. Uh, Professor Kotnala has obtained his PhD degree on silicon solar cell from Indian Institute of IIT Delhi. He has worked as scientist for around 35 years and held positions as chief scientist and divisional head in NPL Delhi. Dr. Kotnala has published over 522 international research papers with more than 10,675 citations, H-Index 50, Google Scholar in ACI peer review journals. Besides that, he has 15 US and Indian patents in his credit, along with 11 industrial consultancy projects, 4 books, and 8 chapters in his contribution. He has also achieved a hydroelectric cell popularity video in masses, in which within the 3 years of duration, he has got more than 1.8 millions, which is a good mark, which is a good in number. He is also a recipient of various prestigious awards and fellowship like Renewable Energy India by UBM, REI Award 2018, Asia's largest renewable energy conservation organization, MRSI Medal Award, JSPS Japan Visiting Scientist, and many other awards he has been chairman of Magnetic Material Committee, Material Research Society of India, MRSI, and he is currently the vice president of Magnetic, this particular society. He is also an elected member as a Sigma 11, which is the world's largest honor society for scientists and engineers, USA. He is a fellow of National Academy of Sciences in India. He is an outstanding academician, Asia Pacific Academy of Material, and is presently the advisor on magnetic measurements on Indian Neutrino Observatory as Raja Ramana Fellow. 21st century biggest invention on green energy hydroelectric cell devices was by Dr. Kotnala and Dr. Jyoti Shah in 2016. One of the credit which is very special is his achievement, or the working I can say, is the water splitting by non-photocatalytical processes to generate green electricity, few drops of water by hydroelectric cells, an alternative to solar cell fuel cells, which is actually a pride to the scientific community. To this, I'll just, it's a long list of, again, our eminent guests to share with you. Now, not taking again much of the time, I would like to request our chief guest of the program and the keynote speaker to kindly share his views about the topic. The title that he has shared with us is the 21st century biggest invention of hydroelectric cell devices to produce green energy, and brief about ISO 17025. Sir, please. We are uploading the slides.
To be with you to talk about a very special topic that on a special day. The special day is our National Science Day, sorry, National Technological Day. So once National Technology Day is celebrated, uh, and we had already one technology that they have already told about it, the India has got. But besides this, what else we can do? Because I was just moving around in AMPRI just before this lecture, I could see a lot of things. The really rural technology, how these are being developed and have been developed in AMPRI, and as well as scientific new pursuits, which are very much required, highly sophisticated facilities. So it's a, I'll say the good beginning to get into the big technology. But I'll not get into the detail of it. I'm thankful to all of you, especially, and as well as to Dr. Akram, who has facilitated our visit. As far as Technology Day is concerned, then what kind of a technology we can give to the nation and to the so that makes a only one point: hydroelectric cell. Then the hydroelectric cell, when we say, it is a device which produces green and clean energy by just splitting the water. No acid alkali is needed for it. And whenever we say that any measurement is to be taken up, so we go for the standards, and that quality standards, uh, most popular is ISO 17025. I would be briefing little bit about it also. And in the beginning, when we say that if it is a ISO 17025, so it has come later on. It's an international organization which has brought a certification. But metrology is the most important part of our science, which is a measurement science. And we know very well the SI systems for which we all work and we understand is a very much needed for all of us. And that makes a ensuring of any measurements through the calibration at a basic level. So on the basic level, uh, whatever we do it, but sometime industry is not following. And if they try to understand, it is essential for trade, scientific comparison, innovations and emerging technologies, technical cooperation, or even simple exchange of information. So that way, metrology has got a very wide scope in which we think that we can really make something. Global quality standardization for sustainable growth of economy and lifestyle. So it's a, why we are looking for global quality standardization. Uh, it's not restricted to the only the in lab. It's for food items. It is for the healthcare. It is for the defense and war. It is in automobiles, which we are using. Then agriculture. In fact, agriculture products are also important. These days, we take packaged foods and even the normal raw foods. There we have to look for the toxicity and other things. So there we look at the agriculture. Also, clothing and diamonds. Diamonds means even the jewelry. There also we go for the global standards. Electronic equipments, which initially we were restricting the inequality system. And for the civil mechanical engineering infrastructure, because that's all being used, whether it is industry or our home. And another very important is the EMI, EMC, and magnetic shielding, where these are the area where you need a stringent quality control. Then ultimately it comes to be that if we talk about standardization, then what are the advantages of the quality in production and testing? In fact, It gives us a flawless production, save resources, boost confidence, and fearless export, because the export can be easily achieved with the global standardization. Countries' economy boosts the demand of products in national and international markets due to standardized quality products. So it's not like this that when we say that quality is restricted to the some of the community, no. Most of the nations and economy depends on the volume of export undertaken by them. That means economy of a nation is ultimately depending on the what kind of a quality products we are producing. So when we come to international quality standards, ISO, if you look at them, there is a different implementations, evaluation, measuring measurements, materials, products, processes, services. It's not limited to the one point. And the most important another is military standards. Quality standards stresses on climate, shock and vibration. Again, for the healthcare, environmental tests expected to see in the materials service lives. The International Standardization Organization, ISO, provides a platform for developing standards through common. There are the other one also, but which is the most popular. I'm talking about that. Common understanding and cooperation with all stakeholders. It contains tailoring information for all types of the tests or other data from the lab to the different methods. Then the organization which I'm looking after also, NABL, National Accreditation Board of Laboratories for Testing and Calibration. What is the role of it? We all know that the NABL certification is quite popular in the country. It provides us effective and speedy implementation of ISO 17025 and the latest version of 2017. When we talk about the industry's quality enhancement, industry and testing lab interaction, hands-on training, innovations, standards and quality infrastructure, international industrial uh, competence with quality assurance, because that's the basic aim of the NABL, so that the quality infrastructure can be established across the whole country in the different fields. So when we talk about the standards of NABL and labs, so NABL operates accreditation program in accordance with the requirement of ISO and IEC. That is the accreditation body, and the following of the accreditation body for NABL is a 17011. The CAPs are the labs, are accredited as per the following standards. You can see the disciplines area standards, whether it's a testing calibration 17025, medical laboratories, ISO 15189, proficiency testing providers 17043, reference material producers 17034. So similarly, there is for the chemical also, and in the accreditation process, what we are, because I'm not discussing the basic requirement of the ISO, because that itself is a one course, and in that one a lot of different things are to be taken care. But in general, suppose you have already developed a quality manual in your lab, which is to be accredited or which is to have a ISO accreditation. For that, there are the different requirements which I'm not discussing. But when you come to the NABL, they will look for application for accreditation by CAP. CAP means lab industry, acknowledgement and security of applications by NABL, document review by lead assessor. Lead assessors and the assessors are the among scientists and engineers who have taken a one already ISO 17025 or other certifications courses, and they have a experience in the measurement science. They are taken as a assessor and lead assessor for the NABL. Final assessment of the CAB is done by the assessment team. Assessment team is mainly from the assessor, scrutiny of the assessment report that is done by NABL, and finally recommendation to accreditation committee, approval for accreditation division, decision by CEO NABL, and issue of accreditation certificate by NABL. So finally, if there is some information needed, and there are the feedbacks which you can see on the sites, that how we have to go for the feedback system, and it takes in general about 3 months time for a lab which is ready for accreditation. And then the next question comes, because whether the lab or industry, they are looking for definitely their business activity to enhance and how it can be done. So it is a acceptance by the government regulators, BIS, FEDA, CPCB, JAM, FSI, MNERE, we talk of Ministry of Electronics and Information Technology, Commodity Boards, Ministry of Food Processing. So you will find Department of Consumer Affairs, Ministry of Health and Family Welfare. So these are accepted as such. NABL accreditation, that if the accreditation to a lab has been provided, so it will be very useful for them to go do the business for lab and industries. Now, after this introduction, if you need some detail, you can contact me otherwise, and to NABL also. But the most important part is whatever is done on today's day, which is Technology Day. 21st century's biggest invention is a hydroelectric cell. You can see the schematic diagram over here. It produces the green energy using no chemicals, particularly acid, base, or electrolyte, except the water. What it is doing, in fact, if I talk about this, so we have developed a material which is brown in color. It's a pellet of 1 inch square, and this one has been generated through by the magnesium ferrite, which we have developed in a lab, which is a oxygen deficient and nanoporous. On this, whenever a water drops come in contact, the water molecule immediately splits into H plus ion and OH ion without any external source. It's basically the process of chemi dissociation followed by the physics dissociation. So that is a sustainable process where you keep on getting H plus and OH ion without any other reason. But the point is, when ions are available with you, H plus and OH ion, unless we separate them and collect, so then you can get the electricity and voltage. And for that matter, what we have done on this pellet, which is approximately 0.3 mm thick, and on this pellet we have put these silver paste, which is acting as an inert cathode, and on the back side, means the other face of the pellet, we have put zinc. So zinc as the anode. So the zinc is attracting OH ion, forming the zinc hydroxide and producing the hydrogen gas. On the H plus ion goes to our cathode, to silver, and where the 2 electrons have been released from the zinc hydroxide formation, and those 2 electrons are now coming to this, and with the H plus ion, they are forming hydrogen gas. So the byproducts are zinc hydroxide and the hydrogen. And it is a non-photocatalytic process, means neither any catalyst is being used, nor we are using any of light or any radiations to initiate the process. And you get a voltage of approximately 1 volt, 0.98 volt on this cell, hydroelectric cell, and the current on the 1 inch square, we are getting 130 milliampere today. But when we initiated 5 years before, when the invention was done, we were having only 8 milliampere current. So you can imagine that how we have moved ahead. These days, when we talk about the energy, so always makes a thermal plants emit CO2, cause global warming effect. CO2 emission by electricity, even by producing this 500 means approximately half kg per kilowatt hour is the from coal thermal power station. So 35% share of the CO2 emission is from the our thermal coal plants. That is why we are restricting ourselves on this. And we can see that glacier melting and as well as the rain, heavy rains and the fire in the forest, all these are creating a problem for our global warming effects because the CO2 is emitting. Why I am showing the CO2 over here? Because in our hydroelectric cell, when energy is being produced, no CO2 is being generated. And in this case, if we look at specifically 1 barrel of oil means the one can see that it produces 150 kg of carbon dioxide emission, not after the once it is being used in the vehicle, but it is while it is being processed, refined. So you can imagine that how intensive is the CO2 gas even in the crude oil reserves. And when we say lesser carbon emission through renewable energy sources, uh, then we definitely think of the our wind energy, solar energy, and earlier hydroelectric dams. But if you look at the facts, then you will find that 28% of the CO2 emission comes from renewable energy sources, 9% from photovoltaic solar cell and windmill in the process of their formation also. So it is not the renewable energy is free from the CO2 emission because in between the steps involved in them are doing this. So that means that in a renewable energy source also we have got the CO2 emission. And the most another important part is when we are using the batteries, solar cell, if you can see on the right side of the picture, it's a solar cell waste once after the use. These are silicon solar cell is put over there. So 10 million, 80 million tons of solar waste by 2050 is expected from this only. And already we are facing an e-waste from the cells where you can see cadmium, lead, nickel, lithium, all is coming and as an electrolyte. So we are in 2019, the world generated 53.6 million tons of e-waste, average of 7.3 kg per capita. Now the disposal of solar panel and batteries is another danger pollution for the environment. But in case of our hydroelectric cell, this is not at all an issue. That is why I am just comparing it. And we know very well there is no planet B. We have to be on this earth. And therefore, urgent need for cost-effective, sustainable, clean and green energy technology to tackle climate change by near zero emission of CO2, we need such kind of the sources, energy sources, which will be green or clean. So again, you can see that the green electricity and we have shown you that you need not to get into you want to get a green hydrogen, or you will just get a dispenser for the water, not the petrol, and one can use them for your purpose. Now, this is a poster which has been published in our one of the latest paper journal in the ACS journal, a graphical representation. What we have shown in this, if we just see it, you will find that the Volta cell, which was around 1800 year, and then finally you can see lead acid battery, solar cell, and the lithium ion battery, and now the hydroelectric cell has come on the now. And you can find out that this has got the best possible applications, and that too all is from India, raw material as well as its concept, working principle, material we have invented over here. So one can imagine that what kind of a position it is putting up hydroelectric cell. I'll show you at the end within the 2-3 minutes that even the display of this. how the hydroelectric cell is working. Now, that will be, you can see here, it's just a simple mechanism how in the oxide material, it's not only we have restricted to the magnesium ferrite, we have been using other oxides also. Around 27 compounds we can observe the hydroelectric cell, and metal oxides, ferrites, all are working on it. And one can see that how simply the ions are coming up from the water splitting. And then it comes a green energy source invention, why it is such a pristine, marvelous hydroelectric cell. If you look at the all kinds of the advantage of it, because as I have said, that even the zinc hydroxide is our very important industrial product, which is a byproduct of our cell. Hydrogen is a green energy, and you will find that there is no problem of the e-waste or any kind of a waste toxicity after the use and the disposal of the hydrogen cell. And today it is we are able to get 25 milliampere per centimeter square. That's the current density. And in solar cell we are getting 30 milliampere per centimeter. But there the voltage we get a 0.6 volt. Here we are getting 0.98 volt. So it surpasses. Solar cell is restricting to the 8 hours a day, but it works for the 24 hours a day. What has been there, if we look at the, we have got the US patent, we have got the Renewable Energy Award in the 2018, a special award on our this, and Complete Energy System Volume is a newly invented hydrogen cell by the elsewhere. One chapter has been in our this one, so one can imagine that it has been taken up soon in 2018 award, then international recognitions getting into the energy volumes. And hydroelectric cell has got the very different salient features, and one can see that how this green energy, what kind of replacement, how it is going to work, all indigenous equipments used in it, and we are getting we have a very high potential to replace our solar cell and fuel cell. It's a portable, easy to carry, no acid, no alkali, only few drops of water, environment friendly, no external energy used, facile, cost effective. It's a very low cost compared to anything. So it has those many important. And if we look at the solar cell, a comparison has been shown here that how hydroelectric cell HEC is for the second column HEC is our hydroelectric cell. One can see that how and the even capital cost is very low. There is a very high, and disposal HEC hydroelectric cell HEC is the bi-compatible. So, but here a huge electronic and toxic waste is coming up from the solar cell. I'll not get into the detail of the working of hydrogen cell because it is in fact I'll say a marvelous piece of interdisciplinary science in the material of the magnesium ferrite, which has been substituted by lithium or by other one, even cerium. What it does, we are producing the oxygen deficient material. So we are using that oxygen deficiency of the material, and then once water is dissociated by them, in an oxygen deficient position, then the hydrogen ion gets trapped into the nanopores, which is our material is about 30% porous, and in that one a very high electric field is generated because nanopore is about 50 nanometer we have taken as a dia, and the length is about 200 nanometer, and you can see that how many nanopores are irregular shape, and then it is one of the nanopore where the physicalization of the water molecule is done through the high electric potential developed by the trapped charge. And finally, it has been the ions have been collected by our electrodes. So electrochemistry has been utilized. You can see that how simple is our chemical reactions happening on it, and finally why we are getting the 0.98 volt on this. And if we have to prepare, it's a very simple, like standard technique, ceramic technique. We have used solid state reaction method, that we are processing the material, and we do the calcination process or around 800 degrees C. And after that, we put into the pellet form. These are the original pellets, 1 inch, it's a 2 inch. And later on, it is put for our sinting around 1000 degrees C. And after that, this pellet is ready for the hydraulic cell, and we just put a um, silver paste by the brush on the top of this, and on the back side we put a thin sheet of the zinc to get this. So it's such a simple process, but the science is interdisciplinary field. These are the original pictures of our cell, which I will show you, given the original piece with me, how much zinc hydroxide is formed in the cell. Then again this how the mechanism works for the water, in which plane it is getting into it, and how the water is being dissociated, how the H plus ion is normally we call it a H2O plus ion, hydronium ion. It is hopping on the surface of the material, whether it's the oxide or the ferrite. In this, we have taken the how much stress when we have substituted the lithium. So in this, our ferrite material, more fringes have been shown. We have taken the TAM pictures of it. Then with the impedance spectroscopy, we have seen that how the resistance decreases so low. Impedance has decreased to a very low, the few ohms from the mega ohm, because of the water dissociation into the material. And if we look at this small peak, we find that the H plus and OH ion tells that the presence of the both ions. Because ultimately, when we say that something is being done, here are the SEM pictures where you can see that how much porosity of the material has got, and the bed surface area we have calculated for them, for the material, which is approximately 100 meters square per gram. And to again direct measurement of our H plus ion presence on the surface of this, we have gone for the electrostatic force microscopy, which has been measured to show that really H plus ions are happening. And of course, the later stage, we have one can see that the worldwide some of the efforts on innovating sources of electricity generation using water was being done. These were from different institute, from the Germany, from the Ireland, from the US. The papers were published during our time when we were trying to to invent ourselves. And later on, these all work have been, because these are the others work on the water they are using with the hydrophobicity of the water, and then using in the cement mold, and then putting with the graphene and getting the something values on it. But all those papers are now not extended further, because our work, we have published more than 30 papers in the journal. Other people have published around 20, so 50 papers have been already published in such a period of 3 years, small period, where we say that how much application it is going to have, which is this. It is our original box in which we have kept the hydroelectric cells, which are here. These are the 3-inch cells, 3-inch cells put into the stack, and then they will be used for the drone. They will be used for the batteries. They can be used for the electric e-rickshaw and the power backup. And these are the in lab, which we have shown, like from the 2-inch a torch, how much bright one can have, and the lamp, how it can be. It's not only with our magnesia ferrite, where magnesia ferrite is brown in color, but we have gone for the tin oxide also, because which is again a very biocompatible material, and other oxides, whether it's a MgO or CO. And then it's a green D also, which we have. We are lighting, electrifying through the 3 small pellet type hydroelectric cells, and 1 LED is being run. Only you have to put the few drops of the water, and you can get the lighting in the dia for 48 hours. Then it can power in the rural village by hydroelectric cell or so. Different applications possible. Emission CO2 from candles burning, it can be avoided because we will have this type of the candle. We have already in a lab prototype. We have already got constructed through our hydroelectric cell. So how much CO2 we can reduce? So we have already estimated. So hydroelectric cell candles for 0 emission. From the CO2 and petroleum matters, nothing will be there. Replacement of batteries by hydroelectric cell, it can be taken up easily. Then the cleanest fuel, which can be produced by the hydroelectric cell, but in a reverse mode. Reverse mode means what we are doing, we are putting a low power. You can see here, cells are here. Again, it's already a working model with us in lab. Anyone can come and visit, low and external powers, and then we are able to generate. What we'll do, we'll apply the 5 volt and then the 2 ampere current, and we get a lot of hydrogen, that to high purity, 99.98%, only with the water. So that's a way. Then it can be used for even that electricity can be taken from this silicon solar cell panel. So I'll thank for your kind attention on this. And now I would like to just show you that how hydroelectric cell can work. This is one can see it is a small 1-inch cells in my hand, which I was showing you. It has got a zinc the back, in the front it's this, and here is this. So this is a magnesium ferrite, which is a lithium substituted. The hydroelectric cell, a complete hydroelectric cell. It's a very lightweight. And here I'll show you with the, rather than this, these are so many LEDs connected. And here you will find these are the white. White are the SNO2. These are the SNO2 cells, means from the SNO2 metal oxide, we have done it. I will pour a water into it, into the water. You will see that it will immediately start glowing. Take up. I'll put water into this. And can you help me a little? Connections were just reverse, right? So I have reconnected them. आप ये देख सकते हैं मेरे हाथ पे हैं, ये आपके LEDs हैं, ये जल रहे हैं. So many LEDs. Now these one will be working for at least 1 hour with the same intensity. And if I have to do it, I'll be putting more water into it. And you can see that I'm holding everything, and such a simple way of doing. तीनों cells को series में लगाया. One cell is now producing 1.2 volt, and the current is approximately in this one is 180 milliampere, because SNO2 is showing a bigger uh, energy density than the our miniature ferrite. So we are working on the different materials. This is here. One can see on any of the direction what is happening. So I wanted to demonstrate it. That's a complete indigenous system. All equipments, furnaces have been from the India only, and the material, its working principle, name we have found. So this is what is a technology on a today on a technology day. This is the one of the best way of showing the our invention with a technology, with a working model. I think let's say right. I think with this I'll just close it, and thank you very much to all of you, and especially to Professor Srivastava to be provide me an opportunity with. Thank you.
Thank you very much, sir. Thank you, Chief Guest and keynote speaker, Professor Kotnala for such an informative, unique, and nice lecture. Sir, in lecture, basically, initially, it consists of the accreditation process in a very simple manner. You have shared it with us, which was then followed by the unique aspects of the invention is of your hydroelectric cell. You have wonderfully covered the comparison between the other cells and this hydroelectric cell, which shows that there is no emission of carbon dioxide as compared to other processes. You also talked about there is no emission of e-waste and portable, and it is easy to carry, and there are very more silent features of this technology that you have shared it with us. You have rightly said, sir, it is a marvelous piece of interdisciplinary sciences. And we not at the same time we were talking about the lecture, but at the same time you have shown the practical aspect of this particular technology, this particular invention live to our viewers. We are really amused and we are really excited to have this in more elaborated form. Thank you so much, sir, once again for this lecture and very informative and useful unique invention that you have shared with us in this very special auspicious occasion day. Thank you so much. Now, I'd like to request our director, CSIR-AMPRI Bhopal, to kindly present a souvenir to our chief guest of the CSIR work, which is made up of parali, as a token of respect and memory to our chief guest, Professor R.K. Kotnala. So, ladies and gentlemen, you can see that this souvenir is made up of the AMPRI technology, which herein we have used the parali for making this particular composite, and then we have developed this particular souvenir. Here you can see that sir is presenting the souvenir to our chief guest, Professor R.K. Kotnala. And this is a work which shows that how we are disseminating. We have the excellent expertise in AMPRI for converting the material, processing the material into a useful material. And you all know that there is a problem of parali going all over. And this is a best example wherein we can help our society. We can develop these type of composites, and then we can help the society. This here our guest, and you can see that uh, yeah, they're opening it, and I think you can see that directly also. This souvenir that we are presenting to our respected chief guest of today's program. Thank you so much, sir. Thank you. Thank you so much, sir. Here you can see the live, this souvenir from Parali Composite. Here, I think you can see easily a complete vision, a complete picture, a frame wherein we have this Parali Composite and our chief guest and our respected director, sir. the souvenir from CSIR-AMPRI Bhopal to our chief guest.
कंपनी का नाम है ना जो कंपनी अच्छा ये तो एम्प्री का है अच्छा वैसा शायद कंपनी का ये सारा ये तो यहाँ पे मैं देख के आया हूँ
There is a discussion going on between the chief guest and respected director, sir. Thank you so much. Thank you so much, sir. Ladies and gentlemen, to proceed further, we have another very, very important and a special event on this day. That is the signing of MOU between our institute, that is CSIR-AMPRI Bhopal, and PSG ITech Coimbatore Institute. We have with us these special guests, Dr. M.I. Abdul Alim, Professor and Head Department of Civil Engineer, Coimbatore, and his colleague. And as Sir has shared that long way they have covered to come to this particular place to have the MOU signed in this special occasion. We are really honored to have you all here in this occasion. So I'll now request Dr. S.K.S. Rathod, Chief Scientist and Head PPD, to kindly execute this particular event of MOU. Sir, please. The signing of MOU and this process has been going on. We are really thankful to our guests who are physically prepared and made this particular event of this signing, including in this National Technology Program, a successful one. The process is going on, ladies and gentlemen, of this MOU. As all of you know that change is one of the step wherein we can collaborate our researchers, the students, the scientists, they can use the facilities, they can exchange their knowledge, they can have a very much opportunities, open-ended opportunities to do the research work. And really, we are very sure that in the near future, it is going to have a good and a fruitful results, and which will be definitely to the society. Here in the screen now you can see that live. We have all our guests present for this particular program of MOU signing. It has been done. Thank you so much. This has been done. Thank you so much. Thank you so much. This another important event we have completed successfully. MOU signing with the Institute PSG ITech Coimbatore. Thank you once again for physically presenting over here and coming over here. Now to proceed further, we are at the end of our this particular program of celebration of National Technology Day. Now I'd like to invite our senior principal scientist, head and coordinator of today's program, Dr. Muhammad Akram Khanji, to kindly deliver the vote of thanks, please.
Thank you so much, Dr. Sarika. Am I audible, please?
Yes, sir, you're audible.
Thank you. So, good afternoon to all of you.
Sir,
Hello.
yes, sir, video.
Is it coming?
We are able to hear you, but video we are not able to see, sir.
Yeah, I think there is some technical glitch probably. Let me try.
There must be some internet glitch.
Yeah, I think there is some problem. Kindly allow me to continue. There is some problem, some technical glitch.
Yeah.
Thank you so much, sir. So, thank you very much, Dr. Sarika, for giving this opportunity to me. At the outset, let me say that it is indeed a great honor for me to propose a vote of thanks on this important occasion of National Technology Day. As coordinator of this event, let me begin by expressing my heartfelt thanks and sincere gratitude towards our honorable chief guest, Professor R.K. Kotnala sir, Chairman, National Accreditation Board for Testing and Calibration Laboratories, NABL, New Delhi, and is also Raja Ramanna Fellow, Department of Atomic Energy. Sir, we are highly thankful to you that you have kindly consented to be the chief guest on this important occasion, and also very thankful to you for gracing this occasion in person at CSIR-AMPRI today. Sir, all of us have heard your keynote lecture with lot of interest and focus, and through your keynote lecture and through your interaction with scientists during the lab visit, I can say that all of us are extremely motivated after listening to you and after interacting with you. Personally, I feel very honored and fortunate that I have been able to talk to you more informally yesterday also and in between also. So thank you so much for giving that opportunity to talk to you and also meet you in person, sir. Through your vast experience, sir, and through your words of wisdom, we all have been really enlightened, not only with various aspects of science and technology, but also with quality management system, which you have covered today in your talk, and which is really very important in R&D organizations. It was indeed a great honor to listen to you on this day of national importance. Sir, once again, thank you for taking out some of your very precious time from your busy schedule and for visiting CSIR-AMPRI on this important occasion of National Technology Day. I would also like to place on record my sincere and deep regards and thanks to our director, respected Professor Avnish Kumar Srivastav sir, for the guidance and motivation given to us throughout the planning and execution of this event. Sir, you have given us ample time from your busy schedule as and when required to ensure that National Technology Day turns out to be a successful event. Thank you very much, sir, for being there to guide us and to see to it that the day becomes a very important and a very memorable event for CSIR-AMPRI. I would also like to thank and also congratulate Dr. M.I. Abdul Aleem, Professor and Head, Department of Civil Engineering, and Dr. M. Alagar, Research Consultant, who are our distinguished guests today from PSG Institute of Technology and Applied Research, acronym PSG ITech Coimbatore, who have come all the way from Coimbatore to Bhopal for signing of this important MOU between CSIR-AMPRI and PSG ITech during this program. Sir, we are sure that through this MOU, there would be much more effective, stronger and productive connect between CSIR-AMPRI and ITech Coimbatore. This MOU gains a lot of importance as it is signed on this important day of National Technology Day, and that too in the presence of Professor R.K. Kotnala sir, Chairman NABL. I would also like to express my sincere thanks towards my colleague Dr. P. Ashokan, Chief Scientist, CSIR-AMPRI, for his untiring efforts towards signing of this MOU. And also I would like to thank Dr. S.K.S. Rathore, Chief Scientist and Head, Planning and Performance Division, PPD, for formulating the MOU successfully. Let me take this opportunity to thank all my scientist colleagues, Dr. Surinder Kumar, Dr. Muhammad Ashik, Dr. N. Satish, Dr. Raju Khan, Dr. T. Shabi, Dr. S.A.R. Hashmi, Dr. P. Ashokan, and Dr. Manish Mudgal for explaining the scientific activities and R&D work being carried out in the lab to our Honorable Chief Guest, Professor R.K. Kotnala sir, during the lab visit in the first half today. My sincere thanks also go to IT team of CSIR-AMPRI, especially Engineer R.S. Ahirwar, Chief Scientist, and Shri Narendra Singh, scientist, in successfully organizing the second part of this event on virtual platform, which we are witnessing right now. I would also like to express my sincere thanks to my colleague, Dr. Sarika Verma, principal scientist, for very smoothly conducting this event on the virtual platform. Let me thank all my colleagues of CSIR-AMPRI, including administration, finance and accounts, stores and purchase, security, horticulture, and other departments of the institute who have been involved either directly or indirectly in making this event a grand success. I thank all of them for their constant support and cooperation during this event. Last but not the least, my special thanks go to press and media for covering this event and for giving it wide publicity. Thank you all. Namaskar.
Sir, thanks
Sir,
to
thanks
all of
to
you.
all of you.
Thank you.
Thank you.
All the best for
All the best for
2020.
2020.
Thank you so much. With this, we end our program. Thank you, sir.
Thank you. Thank you very much, sir. Thank you.